Welcome to chemistry class. Today let me discuss about part 5 of bridge course basic in chemistry. Four parts till yesterday. Until video previous videos we have completed. This is the fifth part. In this we'll discuss three concepts. In this video we'll discuss three concepts. The first concept is accuracy, second one is precision, third one is scientific notation, also known as exponential notation. The three are required to understand chemistry calculations. For chemistry calculations, these three are more important, especially in analytical chemistry, because we know chemistry has four parts: organic chemistry, physical chemistry, and analytical chemistry. Like that, we have four parts. In all these things, these concepts are required as the basics. So, let us start. What is accuracy? So, let me define the meaning of accuracy. What is accuracy? ACCURACY. Accuracy means it is a measure of, it is a measure, MEASUR, measure of difference between, the difference between, measure of difference between, measure of difference between the experimental value, the experimental value means what? The values what we are getting in a experimental value, and the true value, true value means actual value. The difference between experimental value and the true value is nothing but the accuracy, is a measure of the difference between experimental value and true value is known as accuracy. How much of close to the true value? If the experimental value is very close to the true value, we can say it is more accurate. Generally, in analytical chemistry or in experiments, we will not get exact value. So near values we get. The how much of near value is accurate, that can be determined. That measures accuracy. How much of accuracy is there in experimental value as compared to true value. So I'll take one example. I'll take one example. So that example is, let me consider the true value is, true value is 450 is there. Let me consider whatever may be ml or milligram, whatever may be. True value is 450 is there, and a student, and a student performing experiments and is got, student got experimental values as, experimental values as, experimental values as 445, 450 and 455. Like that he has got. Let me consider. Let me consider. And B student got, B student got experimental values as, experimental values as, experimental values as 451, 450, 449, like that he got. And in these two, which one is very close to true value? Student B is close to true value. So B experimental values are more accurate than A student experimental values. A student also got 450, but 445, 455, they are far from the true value. They are not close to the value. But in B student, 450, 450 true value one time he got. First time he got just one value, just close to the true value he got. Second time he has got 449. That is also close to true value. So when it is very close to the true value, that value is more accurate, and accuracy is more for B student, and accuracy is more for B student, and in this case accuracy is less for A student. Accuracy is less. B student has got more accuracy values, A student has got less accuracy values. That is called accuracy. Let's come to precision. What is meaning of precision? What is meaning of precision? Accuracy is this, and precision. Precision means it is the difference between, it is the difference between, it is the difference between measured values and arithmetic mean value. Measured values, measured values and arithmetic. The spelling is Arithmetic. Arithmetic value. So means average value, approximately average. Arithmetic mean value, simply we can say. Arithmetic mean value. Arithmetic mean value is known as accuracy. It is the difference between experimental value and true value is called accuracy. It is difference between measured values and arithmetic mean values. The same thing let me consider here. For same thing we let me consider, and to understand that one here, A student experimental values for is A student experimental values 445 is there, 450 is there, 455 is there. What is the arithmetic mean value? These are measured values. These are measured values. These are measured values, and mean value if you take, mean value if you take 445 plus 450 plus 455 by 3, if you do, how much of value you will get? 445, 450, 450, 450, 900, 905, 905, 1300, 1350 by 3 we are getting here. 1350 by 3 means 3 ones are 3 fours are, and 1 will be there. So 15 means 3 fives are 450 we are getting here. 450 we are getting. So difference between measured values and arithmetic mean value. In this case also is A student, and B student if you take, B student if you take, B student if you take, and in this case measured values is 451, 450, 449. So if you sum that one, 450, 450, 900, 901. So same thing, 1350 we are getting here, 1350 by 3 we are getting, and same 450 we are getting. So here, which one has more precise, more difference? Where we are getting more difference is the difference between measured values and arithmetic. Here 455, 450 difference is 5 we are getting. Here 451 and 451 we are getting. So it is more precise, less precise. It is A student has less precise. A student has less precise. B student has more precise, because the difference here is only 1 is there. Whereas in this case, the difference is 5 is there. So the difference between measured values and arithmetic mean value is called precision, and the difference between measured values and the true value is called accuracy. Like that, you can check accuracy and precision. Once again, I am saying accuracy means it's the difference between measured values and true value, whereas precision means it is the difference between measured values and the average value of is measured values. Average value of is measured values. So that is called accuracy and precision. Accuracy and precision. Definitely you should be differentiate that two. They looks like same. Difference between true value and measured values is called accuracy. Difference between measured values and average of that measured values is called precision. So this is accuracy and precision. Let's go for the next topic. Let's the next topic in this video. I told you, no. So next topic, that is scientific notation. Next one is scientific notation or exponential notation. 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 That is also important for basics in a chemistry. Next topic is scientific notation. Scientific notation. We can also say this as exponential notation. We can also say it as exponential notation. Scientific notation, also called as exponential notation, is very important for our chemistry numericals. Why means most numericals may contain thousands, hundreds, 10,000, 10 power of 8, 10 power of 6 values. So if that values are there, don't do addition, subtraction, multiplication, division with that values. First convert that into scientific notation. Then let me do that one. So nine scientific notation compulsory is needed in numerical values. Let me see what is that scientific notation. Suppose generally in scientific notation the values should be represented. In scientific notation the values should be represented. Should be represented. The values should be represented in the form of in the form of n into 10 power of n format. In this format form, we have to represent the values, whatever the value. It is single digit value or two digits value or decimal values or less than one values or more than 9.9999 values. Whatever, it should be measured in this. Here, n means the value should be between the value should be between 1 and 9.999. It cannot be more than 9.999, cannot be less than 1. the n value. Capital N value cannot be more than 9.999, cannot be less than 1 point less than 1. So, and here small n means exponential value. Exponential value. Exponential value. How we represent this exponential value? I'll explain. I will explain. Suppose if the value is, I'll take one example. If the value is example 1, I'm taking example 1. If the value is 148.56 is there. 148.56 is there. Don't use this as it is. Why? Because it is not in scientific value. During numerical calculation, you should be must and sure you have to write the value in scientific. This is not scientific notation. You have to convert that into scientific notation. You have to convert into scientific notation. How to convert into scientific notation means this decimal value you have to move towards left side. In this case, decimal point decimal point should be moved towards should be moved towards left side, should be moved towards left side. How many digits you are moving, that much of small n value will be there. How many digits you are moving towards left side, that much of n value will be there with the positive. Number of movements equal to number of n value, amount of n value. Number of movements towards number of movements towards left side. Number of movements towards left side is equal to amount of n value, is equal to amount of n value, that is small n value. Here we, the scientist, I already told you the capital N should be more than 1, less than 9.99, I told you. So it should be the decimal point should be moved towards 2 digits, towards left side with the 2 digits. So on that movement, the value becomes 1.4856 into 10 power of 2. Why it is 2 means I have moved this decimal point towards left side with the 2 digits. By 2 digits, I have moved this decimal point. That's why I wrote it as. So the number of movements towards left side is equal to amount of small n value. If the value is more than 9.999, this should be considered if the value is more than if the value is more than 9.9999, definitely you have to move the decimal point towards left side. It should not be moved towards right side. The decimal point should be moved towards left side if the value is more than 9.999. This is example 1. That's why I moved this one towards 2 digits. That's why I wrote it as 10 power of 2. This is scientific notation value for us. This is not a scientific notation. This is scientific notation. And I'll take one more example. Example number 2. Example number 2 I'm taking. Let me consider the value is 0.000, like that. Let me take 0.000, 0.00014, same thing. Let me take 148 52 is there. 14852. If we have the value like this, it is less than one value. It is less than one. If the value is, if the value is less than 1, if the value is less than 1, if the value is less than 1, the decimal point should be moved towards right side. In this case, in this case, the decimal point, please be careful, decimal point should be moved, should be moved towards, should be moved towards right side, should be moved towards right side. Here should be moved towards left side. If the value is more than 9.999, the decimal point should be moved towards left side. How many movements you have done? That should be the exponential positive value. If the value is less than 1, here less than 1 is there, so the decimal point should be moved towards right side. The number of movements towards right side is equal to amount of n value in negative terms. The number of movements, number of movements, number of movements towards right side, towards right side, towards right side is equal to amount of, is equal to amount of n value in negative terms, not positive terms, in negative terms. Here this n value should be in positive terms. If the decimal point is moving left side, the n value should be in positive term. If the decimal point is moving right side, the n value should be negative terms. So here, this value, this decimal point should be moved towards right side up to what value? Up to more than one value, up to less than 9.999 value. We have to move the decimal point up to more than one value and less than 9.99. So if I move this decimal point up to more than one value, I have to move this decimal point up to how many digits? 1, 2, 3, 4, 5. Because one point, to write one point, I have to move this decimal point up to 9. So if I move that one into 5.5 digits towards right side, the value becomes 1.4852 into 10 power of minus 5, because I have moved the decimal points up to 5 digits. I have to move this decimal point up to here, because then only it becomes more than one value. So on that moment it is becoming 1, 2, 3, 4, 5 digits value we have to move towards the decimal point. So the number of movements is equal to number of n value in negative terms. That's why minus 5, because I have moved 5 digits. Like this, you have to write the scientific notation. This is not scientific notation. This is not scientific notation. In this example, the value is more than 9.999 is there. That's why we have to move the decimal point towards left side, and we have to write that n value, that number of movements as n value, exponential value in positive terms. And in this case, the value is less than 1, so we have to move the decimal point towards right side. The number of movements is equal to the amount of exponential value in negative terms. Here I have moved this decimal point up to 5 digits, so that's why I write minus 5, 10 power of minus 5. In this case, I have moved this decimal point towards left side with the 2 digits. That's why I wrote the value as 10 power of 2 positive value. Like that we have to write scientific notation. So this is a video for accuracy, precision, scientific notation. In next video, let me see another basics in chemistry what we require in part 6. This is part 5. Thank you.